In this video, we are going to discuss this Lab10 as an assembly program that stores the value in an array taken from the user input. This assembly program should also interface or interact with our array1c.c file. Let's get straight into our program. So first we have this segment.data message1 enter array size. This will be printed at the start of our program, and we have these two labels, the num and the array. So the num, it will store the input integers, and for the array, it will set the array with size of 100. So our users could input 100 elements in our array. In segment.text, we have this global ASM main, which we set our ASM main to be global so that we can access it in our C file. In line 21 and to 23, so this is just a fixed or default functions that we need in order to use our stack. In line 25, this is where we print, in line 26, this is where we print the message one, where we discussed earlier the enter array size. In line 30, we move the value of our num into our, we move the value of EAX to our num. So the EAX is the value that will be entered by our user if the user will be asked how much size he or she wants to have. In line 31, we set the value, or we move the value of EAX to our ECX. So we have two values of two labels here now, or one label of num and the register EACX with same values, which is the EAX or the user input. In line 32, we set the EBX value into the array. So the array now is the value of elements that will be seen in our array. In line 33, we set our EDX to have a value of 0. In line 36, we have the segment.data. So this is a separate one function now. This one is separate, this one is separate now. So it has a different segment.data. For this one, this function will simply print out the user input, or will get the user input, or the user input for the elements inside the array. So the user will enter the enter value at array. So the user will input the number of elements he or she wants to put inside the array. In line 45 to 45, that's where we ask the user the elements. In line 47, we set the value of EAX to be same with the EDX, and EDX here is 0. So EAX is 0. So we call and print integers, so we print that integer. So this EDX is set to be the index value or index number for our array. So as this reiterates or repeats, the value of EDX will also increase, like for index 0, for index 1, for index 2, for index 3, and so on and so forth. And it will print out this array message 2. Actually, this is just the square bracket that's encloses the number of index in our array. And lastly, it will print out the array message t, which is the array contains. It will print out the value of our, or the number of elements inside our array. So in line 55, we set the value of EBX to be 4 so that it can proceed to the next level of the stack. In line 56, we just simply repeating this process until all of the elements will be entered by our user, depending on the array, the number of array, or the number of elements inside the array set. So in line 64, we have this function or block of the unsorted array. So this will simply print out all the values that were entered initially by our user. So this will not be sorted. This will not will be sorted yet. In segment.data, so this one is different now since it has different segment.data and segment.text. This one will print out the unsorted array. This one will print out the sorted array. For our sorted array, we simply print out the array message, which is the sorting array, and the sorted array is, so it will print out all the elements inside our array that we've already sorted. So in our call print, in our push EBX, so we put the EBX inside our stack. And push the word num, so we put the num in our stack that will be used as a parameter in our bubble sort. So the parameter that will be used in our bubble sort is EBX and num. And then we will call on the bubble sort. So we're gonna discuss it later. We just finish this block first. So the value found in the num will be stored in our ECX. And again, the value of EDX will be set to 0. And it will print another message that is message 5, which is the sorted array is, and it will print out all the values inside the stack that has already been sorted. In our line 96, we have this display array. So we move the value of EBX plus EDX in our EAX. So the EBX is ESP plus 4 and is equal to 0. So this one is depends how many reiteration we have in the sorted array. In line 102, we add the value of EDX with 4. So again, the initial value of EDX is 0. So every time this repeats, the value of EDX will be added with 4. And this will be repeated or looped. And after this is all done, this will jump in our done program. The done program will just simply print out the value done and will return all the registers that were used into their default value. Now let's discuss the sorting programs or the sorting functions. So first, the bubble sort. We have these two parameters, the array and the num. So first, we push the EBP in our stack. Then we set the value of ESP to EBP. So now we have saved the value of EBP, and the next value of EBP will be ESP. In our ECX, the value of ECX will be get from our address EBP plus 8. So the ECX is the number, and the EBX will be gathered from our EBP plus 12 address, which is the array. So in our main sort, this runs externally. So ECX is entered to the stack, and then after that, the value of ECX will increase into 8, so that's the number of elements in the array. Next is the value of ECX will be decreased by 1 every time this main sort reiterates or repeats, and the previous element will be pushed with 0. It will be element to be compared with, and the next element is the element that will be comparing. In our line 144, the switch element will check if it will stop sorting. So these 3 were added in our stack. In line 147, we have these 3 different labels: the first value, second value, and the switch element. For our switch, we have, so this block mainly switches elements placed depending on their values. So this will just compare the 2 values, consecutive values, if which one is bigger or which one is smaller. In line 156, we just simply multiply our EAX with the EDX. In 158, we have the value of EAX will be gathered from our address EBX plus EAX. So it depends on what value is stored in this one. Then it will push this value in the first value. Next, for the EAX, it will move 4 elements or 4 places in our stack, and it will be stored, and the next element will be stored in our EDX. So we will multiply the EAX to our EDX, which is the next element, and we will get the EAX. So this simply will just get the previous element and the next element, and in the index, like for example, index 1 and index 2, it will get the value from index 1 and it will get the value from index 2, and the program will compare which one is bigger, and it will switch places if ever that they have different values or the other one is greater that have lower index. And the switch value, so this will just simply switch the values that will be compared. So if ever that greater yung EAX with EDX, it will switch value. If it's not, then it will end switch. It depends on Which one is? So it really will depend on the values of the elements in the two consecutive indices. So now we're going to discuss the end switch. So in line 196, it will decrease the ECX. And in line 197, the value of ECX will be stored in our EAX, and it will be compared with 0. So take for example, so the value of ECX is the value that is entered by our user. Like for example, the user entered five elements in the array, or the size of the array is 5. So it will decrease every time. So this will reiterate or repeat 5 times until it reaches the 0 value. If it reaches the 0 value, then it will go to end sort. If it's not, then it will just simply increase the value. So for the element, it will increase with 1. Same with the next element. Then after that, after they've been increased in sizes, it will go back into switch, this one. Now in our end bubble sort, so this will just set the return value as EBX and pops EBP in our stack and return to the caller. In our end sort, it will determine if the external loop will terminate or continue. So it retrieves the current loop for the external loop, and in line 214, it will decrement the value of ECX, or ECX minus 1 every time there is a repetition. And if it's equal to 0, then it will end the bubble sort. And in line 218, it will switch element. So the value in our switch element will be stored in our EAX. And it will compare if it's equal to 0. If it is, then no swaps or no switches will be done, and this will end the bubble sort. And if it's equal to 0, then it will end bubble sort. If it's not, then it will go to main sort. And that's it for the whole program. Now we're going to see if this program works. So we initialize this one with our C sort, with our array1c.c file. So let's try. We have 9 values in our array size. So the first value is 3, 6, 7, 4, 1, 2. And as you can see, the first, this line is not sorted, but this line is already sorted and done. Same with the results that we wanted to have. And that's it for this lab 10. Thank you for watching.